All right, so what we have here is we have some information. I grabbed this from an example in the textbook, but basically this person wanted to see if there was any kind of relationship between how much money somebody made, their income, and how much money they're spending every month on clothing. So they went around and they asked a bunch of people. They took a survey, is what we call it. And with this information, we are going to try and determine if there is a relationship between how much money someone makes and how much money they're spending on clothing. So we are going to go through and we are going to start by making a chart. And in order to make a chart, we want to select all of the information that we're using. So we want both the income and the monthly clothing budget in order to come up with a chart here. So we're just going to click and we're going to drag and we're going to highlight all of those for starters. And then we're going to go up here to insert and we're going to click on chart. Oh, and because I'm all zoomed in, everything is zoomed in right here. So you can move things around by just clicking and dragging. And hopefully yours also created a scatter plot. It also created a scatter chart right here. But if not, you can go up here to setup and you can click on the charts and you can click, and we do want a scatter chart. We do want a scatter plot because that's going to be the thing that is the best way of representing this information here. So now we see that we've got all of these points. And if we think back to yesterday, we said that if the points resemble a line or are close to resembling a line, we would call that high correlation. And so here we sort of see that these are all going in the same direction. They're not incredibly spread out. And so we can call this high correlation. So what we can determine from this information is we can start by saying or determining that there is some kind of relationship between the amount of money somebody makes and the amount of money they are spending on clothing. We don't necessarily know that one causes the other. We can't necessarily say that because someone makes a lot of money, that they also spend a lot of money on clothing. It could potentially be the other way around. Maybe somebody is buying nicer clothes and therefore they are getting a better job as a result of the way they dress. That is a possibility. We don't necessarily know that one thing determines the other thing. All we can say right now is that these two things look like they are related because this forms a scatter plot that resembles a line right here. Does that make sense for the moment? So now we actually want to go through and we want to come up with our line of best fit. So in order to come up with a line of best fit, you want to double click on your graph right here until it opens up the chart editor that I had just had up previously. And once you have the chart editor up, you want to go over to customize and you want to scroll down the customize menu until you find series here. I'm going to make this a little bit smaller so I don't have quite so much on my screen right now. Now, in the series section, once you've clicked on this, you'll see things like the color. You can change the color of your points. You can change the background. You can change the size of the points. All of those things will change how the graph looks. But that's not necessarily what we are looking for. What we want to look for is we want to look down here where it says trend line and has a little checkbox right there. If we click on that little checkbox for trend line, that's going to put a nice line right through the middle of our points. And that is our line of best fit that we talked about yesterday. We can see that some points are above the line, some points are below the line. We even have a point that looks like it's exactly on the line. But that is automatically calculated for us based on the graph and based on the information that we have here. And all we need to do is go into the chart editor by double clicking on our graph. we go to the series, and then we click on trend line. And that puts our line into place on our graph right here. Was everybody able to do that? All right. Now, this trend line, while helpful for describing our graph, doesn't give us too much information by itself. So what we actually have to do is we're going to keep scrolling down. And once we click on trend line, we have options once again to change the color and change the size of the line and everything else. We need to click on 2 additional options to get all of the information we need here. First off, we want to click on show R squared. And all of a sudden, up at the top here, you see R squared equals 0.912. Now, I will save you all of the detailed mathematics on what this represents, but essentially R squared is a way of measuring how closely these points resemble a line. If R is equal to 1, then it is a perfect line and every point is on the line. If R is equal to 0, then the points are spread out entirely and they don't form a line at all. So R is, for the most part, something we're not going to have to worry about, but the closer it is to 1, basically the stronger the correlation is. So here, since we have an R squared that's equal to 0.9, that's a very strong correlation, meaning these 2 things, somebody's income and the amount of money they're spending on clothing, according to this problem, are very closely related. They're highly correlated here. So the last thing that we want to do with this, the last piece of information we want from this graph, is we want to go down here where it says custom label, because when we click on this, oh, no, sorry, not custom label. We're going to go to label and then change it from custom to use equation right here. So, oops. We're going to go to label right here, and we're going to change it from custom. We're going to go to use equation. And what that does is it changes the description that we had up here for the line to, oops, I can't actually highlight it. It changes it to this equation right here. Let me zoom back in so you can see this a little bit better. So we now see that with the line, we have associated 0.312 times by x plus negative 31.2. This is the equation of this line right here as it shows up in slope-intercept form. So y equals mx plus b. Google Sheets went through and calculated the equation of this line for us, and we just went through and we displayed this equation by changing our label to the use equation setting right here. This is the equation for our line of best fit. That is exactly what we were talking about in class yesterday. Is that making sense? Questions on how we got to that stage right there? Okay, so now we actually want to use this for doing something. We want to use this for making a prediction, because let's say we're also asked the question, okay, let's pretend somebody makes $500 for their monthly budget. What would we expect them to spend on clothing for the month as well? We can use this equation right here. We can use this prediction equation to try and estimate what the result would be. So here's how we're going to do that. I'm going to start by labeling out a couple of things. So I want to label out, let's do this over here on the side, predicted income and then also predicted monthly clothing budget. So I'm adding these two things over here on the side. You can also add them down on the bottom here. But I am adding these two things over on the right-hand side. So we can start to make a prediction here. We said that we want to estimate how much we think somebody's going to spend on clothing if they have an income of $500. So I'm going to put the $500 in the predicted income cell right there. And now I need to write a formula based on this equation that I got from my graph right there. So I know that all of my equations, all of my formulas have to start with what? An equal sign. So I'm going to start with an equal sign, and then I'm basically going to type in exactly what I have right here. So I've got 0.312 times by x to start. So I've got 0.312. But rather than saying times by x, I'm going to say times by, and I'm going to click on my predicted income cell right here. So x represents our income. Y represents our monthly clothing budget. So I'm going to click on this income cell right here rather than typing in x, because the formula will take whatever number I have right here and use that number as my x value. Yes. Is that better? So I started with equals because I always start formulas with equals. I've got 0.312, and this time times by cell J5 rather than typing times by x, because it's going to take whatever number I have in J5 here and it's going to use that number as x. Then I'm just going to finish off my formula here. Now I could write plus negative, but rather than typing plus negative, I'm just going to write minus and then 31.2 right here. I don't worry about the r squared. I don't worry about the 0.912. That's not part of our equation. That's not going to be part of our formula. The only things we are concerned with was the number here that's in front of the x and the number that is either added or subtracted afterwards. Now, because this is a plus a negative number, I just simplified that to be minus 31.2 right there. Once I hit enter, that's going to come back with what we expect. So based on this equation right here, we can estimate that somebody who earns $500 is going to spend $124.80 every month on clothing. Questions on that? The 500 I just came up with as a number to try and check. So we can honestly change this to anything. Let's say I change this to be $750. Now that I've got my formula written, that's automatically going to change what my result is right here. But I just came up with the 500 as an example here. When you all are given a problem to work on your own, I will tell you what number to check there. Question? The formula is what we have right here. So that is the, if I click on this, that is the 0.312 times by this cell rather than x, and then minus 31.2 since this number here is negative. For me, it was J5. If you put this somewhere else, then it might be a different cell. but click on whichever cell you are using with your predicted income here. So if you put things in a different position, you might have a different thing other than J5. For me, it was J5 because that's the number, that's where I put the number for the predicted income. Good questions. Other questions? All right, so one thing that I want to do with this is I want to look back here real quick. Okay, one thing I would like to point out. So here it said that this person earned $205 and spent $36 on clothing every month, right? Well, let's see what happens when we plug 205 into our equation here. So I'm going to change this 750 to 205. And here, our equation says that on average, people will spend $33 per month. However, this person didn't spend $33, they spent $36. That is exactly what we would expect most of the time. This equation is an estimation. It's a prediction. It's not going to be 100% accurate because, well, nobody can predict the future at 100% accuracy. But what we can do is we can come up with something that is relatively close to what we've seen. So even though plugging in 205 did not give us exactly 36, it gave us a number that was close. We had 33 as a result here rather than 36. And those two numbers are relatively close. That's what we should expect. We shouldn't expect that our prediction equation is giving us answers that are 100% accurate. That's never going to be the case right here. But what it does is it gives us something that's relatively close. Question? You got 32? Do you have these numbers in here for your equation? Interesting. I'll have to take a look at that. Other questions, other concerns? So if, for instance, you notice that something is different than mine, let's say, for instance, you had 26 in here rather than 36. If you go back and you fix a number, if you change a number, if I change this 26 to now a 36, it's automatically going to change my equation over here. It's automatically going to change the formula. So if I change this back to 36, we see that I now have what I had earlier. So one of the reasons why we're doing this is rather than doing everything by hand is because if we notice errors, if we notice there's something wrong, we can change that one number and it will automatically recalculate our equation here. We would need to change this equation as well because we wrote this equation. We didn't import this equation from the scatter plot. But once again, if we enter a number in that's slightly incorrect, let's say I have 204 instead of 205, then we are going to get our number automatically recalculated there. That is sort of the beauty of using Google Sheets or using Excel, is that these numbers are automatically recalculated if you are using your formulas correctly. Yeah, go ahead.